So here's measurements, and again, you're going to be taking lots of measurements. This is where sig figs come in. This is where using your equipment properly is important. So again, if you are too lazy to use the piece of equipment appropriately, then you don't need to be in lab. If you can't use a ruler and you're in 10th or 11th grade, that's kind of embarrassing. So I know you've learned this before, but you really want to actually understand something so that you can, be an educated human being. You don't have to be a scientist to want to be able to measure appropriately. So just keep that in mind. When we measure things, we are taking quantitative information. And again, chemistry focuses on quantitative a lot of times. And again, it's basic to all sciences. We are going to be using specifically certain ones that we like in chemistry. And again, whenever you measure something, you're just comparing it to something that was previously defined. There is a kilogram in the world, like the number one kilogram that every kilogram is based off of, and I have a picture of it later in the slides here. So, there is something that we have decided on is the standard, and that's what you're comparing it with. So real quickly, already, but we have our system. So we use English. There's only 2 places in the world that actually still use English. And we're one of them, and it's like a small country. And we're just kind of stuck. There's nowhere really for us to go with it. They started the metrics way back in the 1700s. Thomas Jefferson actually said, hey, we should probably switch to this, but we didn't. And now basically what it has come to today is we are so ingrained into English that they tried it back in the 1950s, 1960s, and it's just too expensive, it's too ingrained, and we're kind of stuck. So unfortunately for you, you have to deal with both. You have to deal with the fact that the rest of the world does not use what we use, and they're not changing, so you need to be able to do both. The modern metric system is French, and it was actually formally adopted in 1960 for the United States. And there's 7 base units. We use 5 of them. And again, you all know this, but we use the prefixes to modify them. And again, we use the units. Basically, you can use them to derive things. So I can actually use centimeters, and I can measure length times width times height, and actually get centimeters cubed, which also goes into milliliters, which is huge because we don't have that in the English system. We don't have any crossover. Quarts and inches have nothing to do with each other, which is what makes the scientific methods or scientific modern metric system the nicest. Couple of minor things you want to keep in mind. There's a difference between the mass that you contain and your weight. When we're looking at our metric system, our SI unit is kilogram. It is the only base unit that has a prefix. Basically what it is that a gram is very small and it's not actually that useful in most of the scientific community, so they actually allowed this one to have a base unit on it. A prefix. Your mass is your actual amount of matter. So again, it doesn't matter if I take you to Jupiter, take you to Pluto, put you in a black hole, your matter is the same. Weight is directly proportional to your gravity on Earth. So again, if you go to the top of Mount Everest, you will weigh less, not just because you climbed a mountain, but because gravity affects you less. If you go down to the bottom of the deepest part of our ocean, you would actually typically weigh more because you have more gravity affecting you. So your gravitational pull is your weight. We know length is our meter, time is seconds, temperature is Kelvin. If you need to get to Kelvin, what you do is you take your Celsius plus 273.15, and that will give you your Kelvin temperature. Kelvin is called our absolute temperature because there is an actual lowest temperature that can exist, and it's called 0 Kelvin. At that point, all matter stops moving, which is impossible. So there is an absolute scale of temperature. And the one that's very specific to chemistry is the mole. So mole is something that only you'll see in chemistry, which is the little fuzzy guys around the room right now. And the picture on the right here is the official kilogram. It's stored. It's under 3 vacuum tubes, and there's actually bell-jarred vacuum sealed. And there's actually guards that surround it because it's important. Last thing for this is, like I said before, remember there are derived units, and again, the really nice thing about the SI system is there's connections, and probably the biggest connection is right here, that if I measure something in length, width, and height of centimeters, and I multiply together, that directly converts to milliliters, which can go into liters, which if you think of 2-liter bottles, is nice, and again, we don't have that. And we all know good old density. That is also a derived unit because we're using two measurements being put together, which is mass over volume.